So in section 4, we're going to be comparing two linear functions. So remember, when we compare numbers, we are looking for numbers that are greater, numbers that are smaller, slopes that are steeper, that are less steep, initial values that are bigger or smaller or greater or less than. Those are the types of things that we're doing here. So our key concepts: when two functions have different rates of change, they will intersect. So here are some examples. This blue line has a rate of change of 1, and this one has a rate of change of -1/4, and so they intersect here. Here we have a rate of change of 1/3 and a rate of change of 2, and we intersect over here. And if we would have done chapter 6, I could relate back to that. But as long as they have different, and it could be a sign change, like we could have a 1/3 and a -1/3, they are going to intersect. So if we have different rates of change or different slopes, then our lines are going to intersect. So here we have our first example. For each city, there is a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. Which function has the greatest rate of change, and what does that mean in this situation? So here are 3 cities. We have Eastbury, and at 8 a.m. the temperature was 62 degrees, and between 8 and noon the temperature increased by 3 degrees per hour. And so our rate of change is always with that per or for every. That's our rate of change. So right now for Eastbury, our rate of change is 3 degrees Fahrenheit. So then we look at Topperville. They're giving us the equation, T equals 54 plus 2H, where T is the temperature in degrees Fahrenheit and H is the number of hours since 8 a.m. And so since we're looking for that rate of change, we're looking for what is next to our variable. And so that means 2 degrees Fahrenheit every hour. And then we come over to Hilltown, and we have our times and our temperatures. And so we know that over here we're increasing by an hour each time. So these are all ones. And then over here, 58 to 60 means we increased by 2. 62 minus 60 gives us 2. 64 minus 62 is 2. 66 minus 64 is 2. 68 minus 66, etc. And so we end up with our rate of change for Hilltown is also going to be 2 degrees Fahrenheit. So it wants to know which function has the greatest rate of change. Well, Eastbury has the greatest rate of change. And what that means is that Eastbury is warming, well, Eastbury itself is not. Sorry, we'll keep that circled. Eastbury's temperature is warming faster than Topperville or Hilltown. So, and it's 1 degree, but so each of these, that rate of change is that we are increasing by, so for Eastbury, 3 degrees every hour. For Topperville and Hilltown, it's 2 degrees every hour. And so then Eastbury's temperature is warming faster than Topperville or Hilltown. And so that's how we use rates of change to compare, or our functions to compare. So example 2, same situation, it's just now we're going to compare the initial values of the temperature functions for the 3 cities and then discuss what that means. And so keep in mind, we're talking about since 8 a.m. That's a big key here. So when we read Eastbury at 8 a.m., the temperature was 62 degrees, so that's our initial value there. For Topperville, they gave us the equation, so we're going to look for that B value. So that's going to be the 54, our constant value. And then at Hilltown, since 8 a.m., so I don't need these two because those are before 8 a.m. So our initial value at 8 a.m. is 62. And so it wants us to compare, right? So Topperville has the lowest initial value. And so in comparing, we know that this is lower, and these two were the same. So that's kind of our in our mind comparison. And what do the initial values mean for the situation? Well, for our situation, Eastbury and Hilltown started or were, now 54 to 62 would be 8 degrees. So I'd take 62 minus 54. So they were 8 degrees warmer at 8 a.m. than Topperville was. So that's what we noticed. What this means, Eastbury and Hilltown were 8 degrees warmer at 8 a.m. than Topperville, because Topperville was the lowest temperature. Alright, so now I have one last slide for us in this, and so this is just showing that different ways that things can look at. If we have different rates of changes with different initial values, this is something that could look at like that our intersection would be further away. But we could have different rates with the same initial value, which means that they intersect at that initial value. So that would be like our Eastbury and Hilltown. If we were to graph these, they would both start at the same place, but they would have different rates of change. And then if they have the same rate of change and different initial values, then we would have what we call parallel lines, which means they will never touch. So that would be like when we were talking in example 1, and the fact that Topperville and Hilltown had the same degree change, rate of change for degrees. So Topperville and Hilltown's graphs would be parallel lines. They would look similar to this because they have different initial values, but they have the same rate of change. And so this was just images to help you see, like if we have different rates of change with different initial values, you would have your intersection somewhere else in the graph. If you have different rates of change with the same initial value, it's at the initial value. And if you have the same rate of change with different initial values, then you have two lines that will never intersect. And so those are just things to keep in mind. And that is it for section 4.